So team, let me explain you the flow, like how things happen in companies. Okay. So first of all, let us assume that you are working in a project and there is a website on which you and your team is working. Okay. After some time, on a certain day, the client who is owner of the website or your application says that, okay, we wanted to add some new feature to the application. Okay. So how that process is going to happen? So let's say this is, you can say, requirement to change background color or add any new feature. That request is in my client's mind. So what client is going to do, he's going to raise a ticket. Okay. Now ticket raising can be done on tools like Jira or ServiceNow. Basically, these tools, tools like Jira, they exist so that basically they are used to track the work progress. Okay. Let me explain you how this is going to happen. So first, client, what he's going to do, he's going to go on this Jira software or whatever software they are using. Okay. He will click on create, project selection will be done, task, okay, then summary. So client says add new feature to the application. Okay. And then he will like give some description like feature to add a button. Okay. This is like the short summary, and in detail the client will write much more things. Okay. This things need to be done or so and so. Very long description will be there from the client. Okay. Assignee. So as of now, you can see like whichever developer, I'm not talking about DevOps engineer. First, whichever developer is available, what he's going to do, he's going to take this ticket. Okay. Or client can assign also. Okay. Let's say I am the developer. So it will be assigned to me. Moving forward, like the reporter name will be different. Reporter name is the one who is raising the ticket. That means the client. Okay. So once this ticket is created, it will be created, and this ticket will be assigned to a developer named, let's say, Aditya. Okay. So now developer will start writing the new source code which will add the new feature requested by the client in the application. Okay. So once like let's say developer has written the source code and he has, like, let's say developer is writing the source code. Okay. So he will move the ticket to in progress state. That means developer is working on it. Okay. So basically why I say this ticket can be used for tracking purpose. Let's say developer has completed some tasks, so he will update in the comments. Okay. Let's say completed 50% of the task. Okay. Whatever he's working on, whatever he has done, he will keep updating it so that the client can see the tickets to find out the progress, what is going to happen. Okay. So let's say this is done, and after some time, developer has completed writing the source code for the new feature, and then developer has tested the code also. Okay. He has tested the code, and then he will put the ticket in done status. That means this task is completed. Okay. So that means the developer has completed the task, right? And he has tested the code also. The code is working fine, right? Next step is that developer is going to push that piece of code to GitHub. Okay. Now GitHub, let's say this is our repository. Okay. So developer won't be pushing the source code directly to the main branch. No. What he is going to do, he is going to create a new branch, feature, let's say slash feature dash, let's say 123. Okay. And he will create a new branch. Okay. Once he has created the new branch, then here he will add the source code. Okay. So once that new source code is added to the specific branch, then he will raise a pull request. Okay. Pull request is raised to merge the changes from feature branch to main branch. Okay. So once that pull request is raised, then architect of the project, he will check the changes. If the changes are correct, he will merge the changes. He will merge the changes from feature branch to main branch. Okay. So when the changes are merged to main branch, then automatically DevOps engineer might also be writing a pipeline. Okay. So once that pipeline is existing, automatically it will trigger the pipeline when new changes are pushed to the repository. Okay. So when new changes are pushed to the repository, this GitHub actions, previously, as you remember, we were using Jenkins, right? But as I assume, like at this point, everyone understood how Jenkins work and everything. So this time we are using GitHub actions to do the same thing. Okay. So that GitHub action pipeline will be triggered through a commit, right? Commit will be working as a webhook. So as soon as new commit are pushed into new changes are pushed into the main branch, pipeline starts. First thing that is going to happen, compile the source code, run unit test cases, then we are going to perform SonarQube analysis, then SonarQube code quality check, quality gate check. Then we are going to scan the whole repository for finding out if there is any sensitive data or vulnerabilities in the source code. Okay. Then we are going to perform basically building of the application, generating the artifact. Okay. Now, once you have the artifact, previously in case of Jenkins, we were pushing the artifacts to Nexus repository, right? But here we can upload the artifact in GitHub itself, so that later it can be used. So once this part is done, what we are going to do, one second, let me add this arrow. We are going to publish the artifact to GitHub itself. Once the artifact is published, next step is to build the Docker image for the application. Then we are going to scan that Docker image and then publish the Docker image to Docker Hub repository. And then we are going to deploy the application to Kubernetes. Okay. Once the application is deployed, we can monitor it using Prometheus and Grafana. And this is the whole process that usually happens every time some new changes need to be done on the application. Okay. This is the actual flow that is going to happen in companies, right? Now, flows looks good, but now it's better if we do everything from scratch in GitHub Actions. Okay. So make sure to watch this video till end, because to be very frank team, last time few of you were facing issue while setting up Kubernetes or so. So this time, yeah, commands will be separate, clearly available to you. Make sure to follow the whole video till end so that you don't miss out anything. Okay. Okay. Now, let me explain you what are the phases will be there, which we are going to follow to set up whole pipeline system, infra, and everything else as well. Okay. So let me explain you. Right. So this will be in 4 phases. Right. First phase that we are going to have, let me write it. First phase. So in first phase, what you need to do, you need to set up repository. Okay. When I say set up repository, what we need to do? So basically what you need to do, you need to go to my GitHub account on this repository, click on this fork. Okay. This fork, what it's going to do, it's going to create a clone of this whole repository on your GitHub account. And then you can, from there, you can do the changes in your own account. Okay. So make sure to click on fork. And yeah, if you find this repository useful, make sure to give it a star also, so that it stays up top. Okay. So yeah, that will be the first step, which is to set up a repository. Okay. Once you set up repository, then that means you now have the source code available, and which you can use for building the whole thing. Okay. That will be the first phase 1. Now, phase 2, when we talk about phase 2, it's all about setting up infra. In infra, what things we are going to set up? First, we are going to set up a Kubernetes cluster where we are going to do the deployment. We need to set up runner also. Okay. I know many of you might not be aware what exactly is runner. Okay. So runner is nothing but it's a virtual machine that we are going to configure. Okay. That we are going to configure and add it as you can say add it as a some device on which we are going to run all the CICD command. So we are going to provision a virtual machine, configure that virtual machine, then add it to the GitHub Actions. Okay, add it to GitHub Actions, and this time once it is added and configured, then it will be known as runner. This virtual machine will be known as runner, and complete CICD commands and everything we are going to run on this runner. Okay. Sorry. So in simple words, it's simply a virtual machine on which we are going to execute all the commands. Okay. That is what a runner is. Runner, basically in GitHub Actions, there are 2 kinds of runner. Okay. One is public, one is private. Public runner is available for free, but the thing is it's a shared runner. That means other than you also people will be using it. So we can say if you want to maintain privacy, if you are doing some task for our company, we should not be using public runner. So in that case, what we do, we create our own VM configure it and make it private and make it our own personal runner. Okay, so that's what we are going to do, because as I say, we are focusing on doing the things from corporate way so that we can understand how things happen. Okay, so that will be the second task. Third task that we need to do is set up SonarQube server. Fourth task that we need to do is we need to set up monitoring. Okay, monitoring will be doing later once we have written whole pipeline and everything. Okay, so this will be the phase 2 where we are going to set up infrastructure. Okay, coming to phase 3. So in phase 3 we are actually going to write the whole CI/CD pipeline which we can use, and which using which we can like perform complete CI/CD thing, building application, building Docker images, pushing it, scanning Docker images and everything, and deployment to Kubernetes, right? Phase 4. When we talk about phase 4, so in phase 4 what we are going to do, we are going to build the whole application. In phase 4 we are going to perform the monitoring. Okay, in monitoring, two kinds of monitoring we are going to focus on. One is going to be system level, that is we are going to monitor CPU, RAM and these sort of things. Okay, and second is going to be the website level. In website level we are going to monitor like traffic or so. Okay, on the website. So these are the 4 phases that we are going to perform. Again team, I'm saying make sure to watch the video till end, because if you miss out then again you will say okay, I'm not able to do, I'm facing this issue, because everything I'm going to do from scratch, creating VMs, setting up security group, every single thing I'm going to do from scratch so that you don't miss out anything. Okay, right. So these are the phases that we are going to perform. So first thing, now let me close previous like sessions so that everything I can do from scratch, and it will be much easier for you as well, so that you don't miss out anything. Okay, let me remove everything, and okay, right. Now let me go to AWS account. As of now, if first thing that you should be knowing, like before creation of virtual machine, you should be able to see what kind of ports you need to open. So for me, this is my default security group, and let me show you the ports that I have opened for my inbound rules. Okay, so that you can do the same thing. So these are the certain ports that I opened in inbound rules. All of them are IPv4, and source I have kept open completely so that from anywhere it can be accessed. Okay, ports, 2 ranges I have opened, 3000 to 10,000, because most of the things that I deploy or like run is in this range. And since we are going to use Kubernetes like self-hosted Kubernetes cluster, so for that I have opened this range. Rest also it's 22 is for SSH for connecting to your virtual machine, 443 for HTTPS, HTTP 80, then this is for needed for Kubernetes, and this is for MongoDB in case you plan to use MongoDB. 465 it is going to be for like Gmail server. Okay, SMTP server. This is the specific port on which it will works. 25 is also for SMTP, but usually it is being used in companies, but yeah. Okay, and yeah, so these are the certain ports. Make sure that you have opened, because in future also whatever deployment and everything that you are doing, these are certain ports that are very important. Okay, okay, so now let's do one thing. Let me go to the EC2 dashboard instances. So let us do one thing. First, let us create virtual machines for our Kubernetes cluster. So first of all, for Kubernetes, I'm going to create one master node and one worker node. So total number of instances going to be 2. Name I want to give K8, and Ubuntu machine I'm going to select, and I'm going to select the version 20.04, and instance type it's going to be T2 medium with 4 GB of RAM. Okay, key pairs. Now key pair is the location where you can decide what kind of access method you want. Okay, by default the SSH private key pair is the one. So if you already have this one key pair on your local, it's fine. If you don't have, you can click on create new key pair, provide a name, make sure key pair type is RSA, private key file format is PEM, and click on create key pair. This will create the new key pair and make it download on your local also. So immediately you will see some file name whichever you choose, and it will be downloaded on your local machine. Okay, next thing is to select the network settings. So for that I just showed you like what kind of ports I am using. So for that I have selected launch wizard 2. Okay, storage. So to each one of them I am going to give 20 GB of storage. Click on launch instance, and this is going to create 2 instances. Okay, if I go to pending, we should be able to see both of them. So let me rename them quickly. First name I'm going to put as 𝗘𝗏𝗃 master, which is going to be for master node, and this is going to be for worker node. Okay, so these two machines are created. Let me refresh the page and I can go to running. So let's wait for a few seconds so that both the machines are up and running now. Okay, all states. Okay, it's master is still in pending. Let's wait for a few seconds. Yeah, so both of them are running. So let us connect to them and quickly set up our Kubernetes cluster. So first I'm going to copy the public IP address of master node. Go to 𝗭𝗲𝗃𝗦𝗀. If you do not have, you can download it. It is completely available for free. Okay. So in order to connect to a virtual machine that you create, you should click on session, SSH, public IP address which you copied, and since we have created Ubuntu machine, so username will be Ubuntu, right? And SSH. So here we will go with use private key, and we are going to use the key that we have on our local. I have this DevOps Shack PEM. You can have whichever you create, right? Click on OK, and let me close this and let me rename this to master, right? This will be 𝗘𝗏𝗃-master, and let me create a duplicate of it so that we can set up for worker node also. Okay, and since all of them are using the same private key, so we can simply change the IP address and name. Now for the worker node, IP address is going to be this one. Copy that, paste it here, click OK. Now both these like we are connected now. If I double click on it, you will be able to see both of them are up and running. Okay, great. Now let's set up our Kubernetes cluster. So first Control L to clear the screen. Let me make the font bigger so that you will be able to see. Same thing for worker node. Okay, now the commands to install Kubernetes cluster will be available to you in very easy format. These are the commands we are going to use, right? But you can see key, first of all, these are multiple commands. So if we try to run them one by one, it's going to take a lot of time, right? So I have a better option, which is like to create a script for it, right? I'll show you how. One more thing that team you should know, the latest version of Kubernetes, which is coming on 17th of April. I think it's going to be 1.30. As of now, latest is 1.29 something. Okay, but I'm using 1.28, which is not so old. Okay, so what I'm going to do, copy the whole set of commands. These commands we need to run on master node and worker node. Okay, copy this, and on master node, let me create one second, let me see. Okay, you know team, as soon as you create a virtual machine, first command that you are supposed to run before anything is sudo apt update. If you don't run it, you will face a lot of issues while installing any tools or packages. Okay, sudo apt update. The reason that we have to run this command, because it's going to update the default Linux repository for our virtual machine from where all the different packages are available. Okay, so make sure to run this command first. After that, you can create a script via one.sh, and inside it I'm going to paste the commands that I have copied for Kubernetes, which we are supposed to run on master node and worker node. Okay, so I'm going to save and exit. Okay, and now we need to like give the execution permission to the file using sudo chmod, okay, plus x. Then we are going to provide the file name, which is this one, right? Now the thing is key, this file is become executable. If I do this /1.sh, you can see whatever commands we have mentioned inside the script, all of them are going to run one by one automatically. And you can see this is much better way of running the commands if you have multiple commands, right? Now, same thing we are going to do for worker node. We'll create one script 1.sh, and let us paste the commands that we have copied. Okay, so I will save this. Okay, and see, you see it's white in color, right? Now if I add the executable permission sudo chmod plus x, then file name this ls, you see it's now green. Green means that it has now executable permissions, right? So let us execute it. Now it will be executing one by one, right? Now So on master we have already executed. The second set of command is this one, from here to here. Again, as I say, running like one by one command, it's little hectic. So what we are going to do, execute all those commands in one go, and this we need to run only on master node, as you can see, right? So on master node I'm going to create second script, 𝗏𝗏𝗃. Any name you can put, it's not mandatory that you need to put one or two. Okay, now first command that you see, sudo 𝗗𝗿𝗃 init. So what it's going to do, it's going to create a command which you can use to run on any worker node to make it to connect that worker node to the master node. Okay, let me show you how it works. Let us save this, and again give the change the permission, sudo chmod +x and executable format file, right? Let us execute it and let's see what happens. Okay, as I say, the latest version is like 1.29 and we are running 1.28, so we are not much behind. Okay, so let's wait for this to complete. On worker node, whatever commands we needed to run, it's completed, and for master node it's still running and it may take some minutes. Okay, so wait for it. Once this part is complete, okay, let it complete. Meanwhile, what we can do, we can create our other instances which we need to use, right? So another instance that I'm going to create is going to be for runner. So let's provide the name as runner. Okay, Ubuntu this, and for runner I'm going to take much bigger machine because we are going to set up SonarQube on the same virtual machine as well. So for that reason I'm going to take 8 GB RAM of memory. Okay, and this will be the key pair. Security group will be the same, the one that we had, and storage I'm going to go with 25 GB. Launch instance, and okay, meanwhile it is getting launched, we can see the status of our Kubernetes command, right? So all those commands have been run. Now between them in the logs you will be able to see this command, 𝗗𝗿𝗃 join with a certain token. Now this token is the one using which we need to run this command on our like worker node to connect it to the master node, right? So I have copied the command. I can simply paste the commands here. Okay, you see what issue we are getting. The user is not running as root. Okay, so the error that you see here, right, it is not running as root, right? So let me do one thing, become root now, sudo su, and let me run the command again and let's see what happens. And now you can see it is able to execute it, right? It says this node has joined the cluster. That means in order to execute that join command we need to be root. Okay, do not forget that. Now to confirm if a node is successfully connected or not, we can run the command kubectl get nodes, and it as of now it says not ready. Okay, first of all, two nodes here you see. One is control plane. Control plane is the master node. How do I know? This is the private IP address of my master node, and currently I am on master node, right? Here also you see same private IP address. That means this control plane is the master node, right? Worker node, it says not yet ready, so actually it takes some time to get ready. And now you see, as soon as I run second, now the worker node is ready, correct? So now it's fine, correct? Now we can go here. Let me go to running state and runner we have, right? Runner, as I explained, is the VM which we are going to configure and add it as the separate machine on which we are going to execute all the CICD commands, right? So let us connect to runner first. I'll copy this public IP address, go to my virtual 𝗏𝗏𝗃𝗦𝗀𝗃, create a duplicate, edit this, rename. I just need to change the IP address and the name will be runner. Let me change the color also of the runner to somewhere, let's say blue. Okay, now double click on runner. Runner is running, right? Runner virtual machine is up and running, right? Clear the screen. First command you are supposed to run, sudo apt update. Okay, As you know, like why we need to run this command, so that the local default repository of Linux should like has so many packages, right? So if I want to use packages from that machine, those should be available, right? For that reason, to make them available for usage, we have to run this command. Okay, so the virtual machine is created, and this is the virtual machine which we want to use as a GitHub Actions runner, but it is not yet configured in that way. So how do we configure? So for that, first of all, we need to go to this location. Okay, and let's go to settings, actions, and runners. Okay, here let me remove the previous runner. Okay, it requires MFA. One second, let me. Okay, so I have removed the previous existing runner, right? As of now, there is no runner. So to add a new runner, we can click on new self-hosted runner, and device you can select. So since we are using a Ubuntu machine, I'm going with Linux. And now we have the commands that we need to make a virtual machine runner, right? So first command, this one, to create a directory. Now we are inside this. Second command, we need to download a package. Now this package contains everything that is required for like a virtual machine to become a GitHub Actions runner. So once we have downloaded this package, we can extract it, xvf, and file name is this one. Okay, so it is getting extracted. After that, we have this optional command which we don't need to run. Second step is to configure that, right? So first we need to connect that virtual machine to our GitHub account, right? So for that, I'll run this script, shell script that already existing within the package that we just downloaded, and using a token, it's going to connect to the GitHub account. Okay, now you can see GitHub Action self-hosted runner registration. I can see it says connected to GitHub runner registration. So we need to provide a group runner group name. As of now, we don't have separate group, so we can just go with default. Okay, now runner name it's asking. So let's say I'll just put the name as dev runner. Any name you can put, it's not mandatory that specific you need to put. Okay, now it is asking for labels. So basically, you know, we need to put labels so that when I'm running my pipeline, so I want my pipeline to run on my personal runner, right? So I need to make sure that my pipeline knows on which runner it needs to execute the commands. So that can be done using the labels. By default, these three labels are available, and I'll just skip it because we are going to use the label self-hosted, and using the label self-hosted, my pipeline will understand, okay, I need to execute the commands on this specific runner with label self-hosted. Okay, click enter, and you can see it says runner successfully added. Now it is asking for a work folder. So default work folder is _work. We are not going to change it. And you can see settings save runner is registered. Okay, if I go back to the section runners, you can see dev runner which we just created is like added, but it is offline. How do I make it online? So for that, there is another script. If I show you ls, you see this run.sh executable format, right? This is a script which will bring the runner up and running. Okay, bring the runner online. So you can execute this script by /run.sh. Okay, now clicking enter, and this will make the runner online. And moving forward, once the runner is online, we can create the pipelines and execute the commands. Okay, so let's wait for this. You can see it says listening for jobs. Now if I go back here, you can and refresh the page, we should be able to see the status idle. That means it is online and it is waiting for new jobs or pipelines to be created so that it can start with the execution. Okay, now this is good. So runner is created and Kubernetes cluster is also created. I'm going to open the runner session again because this is like running. If I close it, then runner will be stopped, right? So I open the runner again here. And now what I want to do, I want to set up SonarQube server. Okay. For that, we need to have Docker installed on our machine, which we can install using this command. Let me copy this and paste it here. Okay, and also like Docker commands, by default only the root user has permission to run, right? So I want my other users also have the permission to run Docker commands. For that, we can execute this command chmod 666 and docker.sock. Okay, so let it complete. Once this is Docker is installed, then we can execute that command. Okay, now I can run Docker commands to install SonarQube server. Docker run -d -p, and port I want to give as 9000, which is the default port for SonarQube, right? And Docker image we need to give it, so that using the Docker image it can create the container. So I'm going to use the LTS version SonarQube :LTS-community. Okay, and click enter, and this should create the Docker container for SonarQube, and then we will be able to use that Docker container for our report analysis. Okay, so let's wait for this. Okay, in order to access that Docker container, I can get the public IP address of this runner VM on which the container is created. You can create SonarQube on different server also, that is also fine, but just for the ease of it, I am creating it on the same server. Let me get the IP address, put it here, :1000, and you can see SonarQube server is getting up. Okay, it is getting started. So whatever servers we needed, SonarQube is done, runner is configured, as well as Kubernetes cluster is also set up, right? One small thing that we need to do, we need to add Maven on this runner, because we have a Java project and we need to run Maven commands as well. So let me quickly install Maven, and this is the command using which we can install Maven, right? -y, so that no prompt comes. You might be thinking why we are not installing Java like Maven, because Java we will be directly installing it through pipeline. Okay, so let's wait for this. That is another benefit of like using runner, that separately you don't need to install so many multiple tools. You can install, for example, like for SonarQube server, I'm not even installing SonarQube scanner, right? Because that will be done automatically with the pipeline. Okay, so this is done, and let us log into SonarQube. Default username password is admin, so we can just put it, which we need to immediately change. Let me do it. Old password is admin, new password we can just put as Aditya or anything else you can put. Okay, now we have set up complete thing. Infra is done, monitoring will be doing later. Okay, rest of the things is done setup, right? Now we can get started with writing the pipeline. Okay, so let's do that. Okay team, so now let me explain you how this corporate pipeline should be working. Okay, so let's say what developer has done, he has written the source code for new feature, pushed his information, pushed all the details, like whatever he has created, the new source code, into this feature branch. Okay, after that he's going to raise a pull request by going here, click on new pull request. Okay, and here like he's going to select the branch from which he want to pull like merge changes from this branch to this branch. Okay, as of now there is both of them are same, but just for scenario understanding you should understand key from feature, a developer will raise the merge request mentioning everything, all the details. Okay, these are the changes. An architect will review the changes and approve the merge request, so new source code will be merged to main branch, and as soon as new changes are merged, the pipeline which will like perform or deploy the changes to the application will be triggered. Okay, so obviously if pipeline needs to be triggered, there should be some pipeline written, right? There is no pipeline as of now. So for that, what you need to do, you need to go on actions. Okay, click on new workflow. Now as soon as you click on new workflow, you will see get started with GitHub Actions, and you can select so many default created pipelines. Okay, so for us, we are working with Java based application, so let us go with Java with Maven. This is the basic pipeline. Okay, click on configure, and it will automatically create a folder .github/workflows, and inside this workflows you will be having a pipeline. You can name this pipeline anything you want. That is completely up to you. And there is a small, you can see a small pipeline created, a default pipeline which you can use. And now what we are going to do is modify this pipeline as per our own requirement, and one by one make it much bigger so that we can do the deployment to this pipeline. Okay, now so this is the comments, so I can remove that, right? And let's name this pipeline as CICD pipeline, anything you can put. Then you see this option on, then push and pull. So this is basically a trigger, or you can say webhook, like on what actions this pipeline should be triggered automatically. So what I'm going to set to, I'm just going to set to push. That means if any new changes are pushed to main branch, then automatically this pipeline will be getting started. Okay, because obviously like if developer has pushed their changes to feature branch and raised a merge request, so as soon as merge request is completed, some new changes will be pushed into main branch. So as soon as we have the source code pushed, automatically this pipeline will be started. Okay, now since we selected Java with Maven, so automatically this stage will be added. This is optional, so we can remove this as well. Okay, now you can see here what is happening. First we are defining how many jobs are there. First we have build, okay, which is runs on Ubuntu latest, right? But we have our own runner, so that own runners label we can put here in the format self-hosted. If you remember, this was the label that we choose. If I can show you runner, if I scroll up, you can see here this runner will have the following labels: self-hosted, Linux, x64, right? So any one of them if I put here, then pipeline will automatically understood ki, okay, these pipelines are supposed to be executed on the runner that user has created, which has the label self-hosted. Okay, for that reason I have written runs on self-hosted. Next we have steps. In steps, every step that you write, you will be seeing a specific format. First you will see uses, and you can see here action/checkout, and here also we have actions setup Java, right? So basically in uses there are certain configurations which will set up an environment, or if any tool is needed, it's going to set up that as well. Okay, so the purpose of doing that, see, as I told you, we did not have Java installed. I did not install Java on the runner virtual machine, right? So that Java will be automatically getting installed using this. Similarly here you can see first one we have action/checkout. This means that we are going to check out this whole source code repository on the runner for usage. Okay, once that checkout is done, after that what is going to happen? After that Java is going to set up. Which version we have set up? 17. This you can change as per your own requirement, but 17 is the one that I prefer to use, so I'll just go with it. And from where it is getting installed? Tumerian. Okay, after that we have build with Maven. So Maven we are not installing here, that's why I installed Maven on my virtual machine, right? And here we have second thing, which is build with Maven. So here -b we don't need actually. Okay, and then here you can see --file pom.xml file, right? Sometimes what happens, your pom.xml file may not exist on the root location. So in that case you need to provide the file, the path of the pom.xml file which is happening here. But since our pom.xml file is already on root, so we don't need to put it. But still, if it's here, it's not causing any problems, right? Now, you know what is going to happen now? As soon as I click on commit changes, it's going to start the pipeline, and pipeline will start running. Okay. One more thing, team, on right side you see marketplace and documentation. So these stages that I'm adding here, you can find them here as well. For example, if I search Sonar, so something we should be able to find Sonar scan, Sonar scanner, lot of things, right? So from here itself, I can just put the commands here. Obviously we need to configure them one way or the other, but yeah, from on marketplace you'll be able to find. You can just go on this this URL, github.com/markets place, type is equal to actions. For actions, whatever like specific steps you need, you can find them here. Okay. Now, so let's do one thing, commit changes. As soon as I commit the changes, because we have set up a trigger that this pipeline should be started on push, right? So commit changes, and if these changes are getting pushed to the repository, automatically if I click here, you see this yellow brown color dot. This means that pipeline has started. Okay, either you can click on actions, or here also you can click, which will take you to the build, and here you can see the status. So you can see JDK setup is being done at runtime, and after that is successfully done, next step would be to build the application using Maven. Okay, now let's wait for this to complete. So this is the just a basic pipeline for you to understand, right? Obviously we are going to write the whole pipeline from scratch so that you understand. Actually I have written also a specific format which contains all the stages. Then I'm going to explain one by one all of them. Okay, so do not worry about anything. Okay team, so as you can see, the pipeline is success, and we should be able to see the jar file on this location. Let me show you. If I copy this path, go to runner, okay, cd path, you can see this jar file is created, which is good, right? Now let me come out of it. Okay, so this is running fine, right? Next step is that I want this artifact that is getting created, it should be available to me, other than available, like as of now it's available in the here, right? But it should be available on some repository format here itself. Okay, also I want to execute 𝗃𝗏𝗃𝗦𝗃𝗃. So for that 𝗃𝗏𝗃𝗃 I need to install on this runner virtual machine. So let's do that, and this is the 𝗃𝗏𝗃𝗦𝗃𝗃 commands. I will just copy the whole commands, create a script here. Let's call this script as 𝗃.sh, paste all the commands, save and exit, and change the permissions. Sudo chmod +x 𝗃.sh, right? Permission change. Now I can execute this script to install 𝗃𝗏𝗃𝗃. Okay, now obviously see the reason that I am using this script to install any tools, because running all those commands one by one, it's going to be very hectic, right? You can see 𝗃𝗏𝗃𝗃 is installed, right? And just to check which version we have installed, 𝗃𝗏 version, we can see we have installed 0.50.1. I guess it's upgraded recently. Okay, now so in our pipeline, what I want to add stages for 𝗃𝗏 file system scan and publishing the artifact. Okay, so let's do that as well. Okay, let me show you the commands which I can run. I have set, see these commands that you see here, I have set up them using this GitHub marketplace. Everything for every stage that I want to use, I can just search here, I can find the suitable format, and then I can add it in my pipeline. Okay, that's using that I have written. Now let me show you the 𝗃𝗏𝗃𝗃 and the commands for publishing artifact. Here again you see here uses actions upload artifact. That means this use is going to create an environment or set up an environment using which I can publish my artifact. Okay, so this will be the name of the artifact in which it will be generated in zip file. Let me show you. So I'm going to name it as board game. Okay, and path, which file or folder I want to create as an artifact, this jar file, right? Then we have 𝗃𝗏𝗃𝗃 scan. So 𝗃𝗏, since we have already installed, right? So what I can do here, simply run shell command. Now difference between this shell command and this shell command, let me explain you. Here directly after run I can run the shell command, but sometimes it is possible that you may have multiple lines of shell command, right? So if you have that case, in that case it will be, you cannot run multiple commands in the same line. So for that you can use this pipe, write the command, one command here, then let's say I can simply write echo hello, right? So these two commands, both of them will be running. Okay, now using pipe is the way in which you can execute multiple commands. Okay, but I have just written it simply just to explain you this concept. So now what it's going to do, it's going to build the application, generate the artifact, publish this artifact, this is a jar file, and then also scan the whole file system and generate a report in the format HTML format. How I have written the command 𝗃𝗏𝗃𝗃 for file system -- format. That means in which format I want to get the report. I want the report in tabular format, and I want to generate the report. I want to export the report in a file. -o means like I am exporting it into a file 𝗗𝗲𝗃𝗍report.html, and there is a small dot here. That means I want to scan the current directory. Okay, so this is going to perform that, right? 𝗃𝗲 and publish artifact, right? Next step would be to perform a SonarQube code quality check and SonarQube code quality check, and second is SonarQube quality gate check, right? So for that also I have written this command. Let me explain you as well. Again team, I'm saying ki so this is what I'm saying, ki whatever commands you see, I have basically, you can generate them in the form of template from the marketplace. Okay, once you generate them from marketplace, then you can modify them. Okay, now let me write the SonarQube command. Here you see name is this uses. What it's going to do, it's going to set up an environment for executing the SonarQube commands. As I told you, I did not install any SonarQube scanner which is going to perform the analysis. That's why we are using, this is one of the benefit of using GitHub Actions. You don't need to install too much tools. Certain tools which are already available within GitHub Actions marketplace, you can directly call them using this format in uses. Now here, environment we are setting up SonarQube, Sonar token and Sonar host URL, right? Your question would be, okay, Aditya, this is done, but where exactly is the other details? Like we used to, in Jenkins, we used to write dsonar project name, dsonar project key, right? So those things, what I have done, we can put it in a file inside repository sonar-project.properties. You can see I have added those information here. Okay, that's why we don't need to write them here. Okay, but the thing is ki still we need to provide the SonarQube token and host URL. So for security reasons, we cannot put them in our pipeline, right? They will be exposed. So what we are going to do, we are going to create secrets. First secret will be sonar underscore token. Where do we get the secret? You can go into repository, go to settings, scroll down to secrets and variables, then actions, because we are creating secrets for action. Here you can create variables also. Here you can create secrets also. So I am creating secrets because these are credentials, right? So secret name will be sonar token. Now I can get the token from SonarQube server. Go to administration, security, users, and here we can generate the token, right? Generate, copy this, and we can put it here, right? One secret got generated, correct? Second secret, which is going to be for URL. Even URL, I'm not putting it here for security reasons. I don't want anyone to see the URL of the SonarQube server, right? So again, I can create this secret, copy this URL till 9000, copy that, paste it here, remove the last slash and add secret. Now, if I execute this command, it has everything. First, it has the scanner from here itself, and where exactly it's going to put the report, that information can be received from these two things, sonar token, sonar URL, right? And other things which I have added in the sonar-project.properties, right? Project key, project name, Java boundaries. So it's all set up. Now, next step would be to perform code quality gate check, right? So for that also, what we can do, we can add steps. Okay. Now for adding those steps, I can add this one, check code quality gate. You can see here also we are using sonar token, sonar host, and this is like already this is available. These all things are not coming in template format. We just need to modify them as per our own requirement. Okay. But if you run directly the sonar quality gate check, it's going to give error because you will get an error that JQ is not found. Because basically when we are running this step, quality gate check, it requires JSON query, some parsing is needed. Okay, for that we need to have this, and which is not available by default. So we can simply use this command to install it. Okay, so I'll copy the whole thing, paste it here. Okay, and team, this is like YAML written, so make sure that you don't get issues in bad indentation. For that, what you can do, you can simply copy the whole thing, go to write YAML lint, and here you can paste it and click on go. So this will just let you know if your YAML is valid or not. Okay, now these things are also done. So this step will properly do the SonarQube analysis, generate the report and push the report on this repository. Okay. Next step would be to build the Docker image and push the Docker image. But before pushing the Docker image, we should be able to perform a 𝗃𝗏𝗃𝗃 scan of the Docker image, right? So for that also what we can do. So for that also, as I mentioned, everything that I'm writing, all those steps are available in marketplace. You just need to find the correct one and modify it as per your own requirement. Okay. So for Docker image, this is what we are going to do. First of all, we need to set up this. This is also required for like a Docker only. It's going to set up like environment basically, so that you will be able to run all the commands. Okay. Then we have Docker buildx. Okay. And finally, we are building the Docker image. Okay. So let us do that and let me explain you afterward what exactly happening. Okay. And yes, now here you can simply you can see I'm running a shell command, docker build -t docker image name and a dot because Docker file is in my root directory, correct, that I have written. After that, so once we have Docker image ready, we want to, before we push the Docker image to Docker Hub repository, we should be able to scan that Docker image. That we can do again using 𝗃𝗏𝗃𝗃, right? And 𝗃𝗏𝗃𝗃, since 𝗃𝗏𝗃 is already installed on the that virtual machine runner, so it's not going to be a problem, right? After that, let's say I want to push the files to Docker Hub repository. So for that also we are going to need Docker Hub username, Docker Hub password, right? So let me put that. Let me add this. Right. So let us create more secret. Okay. Go here, settings, secrets and variables, actions, repository secret, Docker Hub username. So here we can put our username, Docker Hub username, which whichever username we are using for Docker Hub account. Okay. Second secret that we need to create is going to be Docker Hub token or Docker Hub password, whichever you want. You can just put it name. Okay. This is going to be Docker password. Okay. Okay. And add secret. So these two things are added now, right? That means we will be able to build the Docker image, scan the Docker image, log into Docker Hub repository, and then push the Docker Hub, push the Docker image to Docker Hub. Okay. Again, you see, interesting thing, uses wherever you see, you can understand. Okay, this is for setting up certain specific environment for whatever task we need to do. You can see this uses, this is for login. Using this, we can log into Docker Hub. Okay, so these things are done, right? Next step. So next step would be to set up Kubernetes cluster and connect it from here, right? How do we do that? But as I said, we are going to follow proper methods, and for that we are going to use RBAC, which is role-based access control. Okay, so for role-based access control, what things we need to do? So for that we need to create certain service account. Then using that service account, what we can do, we can create a role, assign that role to the service account, and then using the service account we can do the deployments, right? So this is the YAML file using which we can create service account. Service account name is going to be git actions svc, any name you can choose. Okay, so I will copy this. Let us create our service account as of now. Okay, vi svc.yaml, paste it here, save this and exit. But before that, one thing you should know, there is a namespace named web apps, but we have not yet created a web apps namespace. So let us create it. kubectl create namespace. What is the namespace name? Web apps. Okay, now if I run this command kubectl apply -f svc, then it's going to create a service account inside web apps folder, web apps namespace. Okay, so once service account is created, next step would be to create a role, and using this role we are going to assign this role to the service account, and then service account will be having specific level of permissions. Let us create this role, vi role.yaml, paste the contents here, save this and 𝗘𝗲𝗃𝗍 apply -f, and this will be role, right? So this is also done. Next step, once we have created the role, and service account, we need to assign that role to the service account. Okay, so for that, let me quickly find the commands. This was inside one of my repositories. Give me 1 second. For you, don't worry, all these steps will be added in the documentation. You'll be able to find that in the Telegram group. Okay, and steps, role, and this is the binding rule. Okay, this will be bind dot YAML, and this is not going to be Jenkins, it's going to be the name service account that we have created, which was this one's, right? Okay, let me copy this so that I can use it in documentation and share it to you guys as well. Okay, now let us save this and apply this as well. 𝗘𝗲𝗃𝗍 apply -f bind. So now the service account that we created, git actions SVC, is having the permissions to perform the deployment and everything, update deployment, delete deployment, view deployment, and everything. Okay, final stage that we need to do is basically create a secret token. That token will be used for authentication from GitHub Actions to this Kubernetes cluster. Okay, so for that we can use this command, and let me explain you what exactly we are going to do. And this will be secret.yaml. Okay, now here two things we can change. First, we need to change the service account name, which is different in our case, right? We have created a service account named, where is it, this one, git actions SVC, right? And service, this name also we can check, like change it, git dash secret. Okay, or maybe much better name will be dash svc dash secret. Okay, save this and 𝗘𝗲𝗃𝗍 apply -f. But in our YAML file we did not mention, where is it, in our YAML file we did not mention anywhere the namespace name, right? Let me, so since we have not mentioned the web apps name, which is the namespace name in our YAML file, so we need to manually put it here, -n, then web apps. Now the secret that is going to be created, it's going to be created inside a web apps namespace. That's done, right? So this is good. Generally, secret we use for like let's say when we are like using CICD tools like Jenkins, where we can use it for authentication. Okay, but here instead of using secrets, we have another option to use. Let me show you. This you see cube folder. Inside cube folder we have a file config. Now this config file contains complete configuration of your cluster, and this is the file that we are going to use for establishing connection from Kubernetes from GitHub Actions to Kubernetes cluster. Okay, so that we can do cat config. Now this is the file that we have, right? Talking about how we are going to use it. So basically what we need to do, let me explain you. This is going to be the command used for deployment to Kubernetes cluster. Okay, so again, as I see, you can see this uses, so it's going to set up the kubectl, so that because you see we did not install kubectl on our runner, right? But it will be done at runtime automatically using this. So let me show you what we need to do here. Go here. Okay, you see there is another secret, 𝗃𝗏𝗃𝗀. Now 𝗃𝗏𝗃𝗀 is the secret which we are going to use to for the authentication basically. Okay, here what we need to put, so here we need to put this content, this whole content we need to put. Okay, so let me explain you. Basically we need to put that 𝗃𝗏𝗃 file inside as a secret inside the GitHub Actions, right? And it's already a secret, so it's not accessible to everyone. Secondly, to make it more secure, what we can do, we can convert it into base64 format. Okay, so that we can do using this command. Okay, one of the another reasons that we are using base64 format is that if you just copy paste directly 𝗃𝗏𝗃 file to GitHub Actions, it won't work, because the format is completely changed and it may not work properly. Okay, so what we are going to do, we are going to convert it into base64 format. Now you see this file, this is single file, right? Correct. Now we need to paste this inside GitHub Actions. Here you can see now nobody can use it, right, except us. Okay, so this is done and this is also done. One more thing that we need to do, let me do one thing. We need to change the Docker image name. We want to use the Docker image that we have created, right, which is this one. So I will copy this, go to Docker, not Docker file, go to deployment service YAML, update the image name. Okay, edit the file first. Okay, and as you can see I'm using load balancer format. Okay, so that we should be getting external IP address, which is much safer than node port, but that option will be available if you are using a cloud-based Kubernetes cluster. Okay, now if I commit these changes, there will be one thing that will be happening is that pipeline will be automatically triggered, which we are going to stop because we don't want to run that pipeline yet. Okay, and it's run. Let me stop it immediately. Cancel. Okay, great. So that is done, right? Now if I do the deployment, if I commit this whole thing for the pipeline, then pipeline will be getting started and then pipeline will be running, right? So let me do one thing. Let me add one more command, kubectl get svc-n pip apps. Okay, so that's fine. Let's commit the changes and let's see what happens with the deployment. Okay, can monitor the pipeline here, or we can click on actions also. Okay, this might take a little bit of time because we have, you can see here. Okay, one thing that I should explain you now, setup job. In setup job, what it's doing, it's downloading all the actions that we have added. We are using kubectl for Kubernetes, login for Docker login, setup, this is for like Docker, this is for SonarQube, code quality check, this is for SonarQube scanner, this is for uploading artifact, this is for setting up Java, right? Now you can see, and we have tons of stages actually. Okay, so let's see how it goes, and if we face any issue, we'll try to fix it. And don't worry, all these files and everything will be in proper format available in your Telegram group. You can just go there and check it out. Okay team, so pipeline is completely success, and you can see all those stages that we have added, everything is ran fine, right? So if I go to this run kubectl apply, this is where we ran the command for deployment, right? First command it ran, deployment was successful, and yeah, this is also running fine. And you can see we have used load balancer as service type. Okay, and in load balancer you are supposed to get an external IP using which you can access the application, but this is a self-hosted Kubernetes cluster, and there is no external load balancer already added here, right? So that load balancer IP address will be available when you're using a cloud Kubernetes cluster, right? But for now, we can use this a port to access the cluster, right? So sorry, to access the application. So we can go to instances, worker node. This is where our application should be running. We can get access to it, right? And what was the port? Sorry about that. Let me get the port. Port was 32409, and let's see. So we can see application is running fine. We are able to log in also. Let me see. Daffy duck. Here we are using a H2 database, which is created at runtime itself. Okay. So yes, we are able to access the application. Okay, this is fine, right? So we have deployed application successfully. Now the time is to set up monitoring for the application, using which we should be able to monitor. Okay, so let me show you that as well. So team, application is deployed, right? Now it's time to monitor the application. Okay, so I am here and let me create a folder. So all the monitoring tools, I'll be putting it here. Okay, monitoring. Let us go inside it. Okay, now first let us set up Prometheus. So for that, you can go to this link. It will be in the description as well and the documentation as well. Okay, for Linux, right? And so I can copy this, copy the link, wget, paste the link, and let it download. Okay, so it has downloaded the tar file, right? Let us extract it, -xvf and the file name, right? So file is extracted, right? So let me remove the tar file. Okay, and let me rename this also because it's quite long, seems quite long, right? I will rename it to Prometheus tool. Okay, now we have this. Now let us go inside this Prometheus. We have these many files, right? Now this file that you see here, Prometheus, this is the executable file of the Prometheus tool. So if I execute this file, Prometheus will start to run. Okay, now how I can execute? So we can simply type /Prometheus. Okay, now if I run it, automatically it will run on the foreground, but I want to run it in the background, so I can put &sign. Now it will start and it will run in the background. Okay, I can simply press enter and see Prometheus is still running. Okay, how we can check? So we can check by going on the I'm running this on runner, right? So public IP address, paste it here, and it should be running on port 9090, I guess. Okay, and you can see it is running now, right? If I go to status, go to target, so here we will see whatever things we add, we can get their like we can get the endpoints details here. So as of now, it's here, right? Now second thing that I'm going to install is going to be black box. There are so many different exporters, black box exporter, we have console, we have graphite. Another important is node exporter, right? Black box exporter can be used for the website monitoring. It is really useful. It can get the probes. Okay, node exporter is used for system level monitoring. So first let us set up black box. Okay, so again for black box I will choose the package. Okay, and let us come out of the Prometheus folder. Okay, and download the black box package, right? Let's wait for this. This is completed. We can see the file. So let us extract it from xvf. Okay, so this is extracted, and let us remove the tar file. Okay, and we have these two folders. Again, I'm going to rename the black box folder because it's quite long, which I don't want. I will just put it to black box exporter. Okay, and now we have these two files. Now let us go inside black box. we have these many files, right? Now for black box exporter, this is the executable file, so let us execute it. And again I'm going to run it in using ampersand, so it runs in background. Okay, now black box exporter, by default it will be accessible on port 9115. Okay, so I'll put it here, 9115. You can see it is running, right? But there is no recent probes because as of now we have not yet configured. So how do we do that? So for that, let us go inside the Prometheus folder. Here you will find one YAML file, prometheus.yaml. Okay, so let us edit this. And here we can provide the URL of the like whatever things we want to monitor, those things we can add here. The format will be inside scrape configs, like black box is going to scrape metrics, it's going to forward it to Prometheus, then from there it will go to Grafana, right? So here we need to add. Now if you are new, you do not know how to do that, you can just take help from this. From this also you can do the whole thing. Okay, so we are going to copy from job till this one, copy this, and yeah, one thing that you need to make sure that you do not forget is that there should not be any bad indentation, so that we need to take care. Okay, and let me see, it looks fine. Okay, replacement, so here we need to provide the IP address of the virtual machine, right, on which black box is installed, which is the same as runner. So I'll just copy the IP address, paste it. Okay, that is fine. Let me remove the HTTP, we don't need to have it as. Okay, this is fine. Next we need to put the information about what exactly we want to monitor. So let's say I want to monitor two things. First is my deployed website, and second will be, let's say, just this prometheus.io, so that we can see if the results are correct or not. Okay, so I will remove this and then get the IP address, get the where our application is running. Okay, where is it? Once again, let me get it. Git master, if I run kubectl get svc-n web apps, it is running on port 32409. Okay, let me, and it should be running on, sorry about that, it should be running on worker node, right? So I can get the IP address of the worker node, and 32409, right? I'll put it here. Yeah, okay, so the application is running on this URL, right? This is the application URL. So we will copy this and let us go to YAML, right? And here we can put it, correct? That means we are going to monitor this application, this website, and prometheus.io using our black box. Okay, so now I'm going to save this. Now one more thing that we need to do is basically restart Prometheus. So for that, since it is running in background, what I can do, I can get the process ID of the Prometheus, then kill it and then restart. For that we have this command pgrep Prometheus. We can see this is the process ID, so I can run the command kill. Okay, now this is done and I can restart again. Okay, okay, sorry, I need to run it in background. For that I can use ampersand. Okay, now let's go to the Prometheus page. Where is it? Yeah, let me refresh it. You can see black box is also available, but it's going to take some time. Okay, let me refresh, and now you can see this is our application, right? So now all these endpoints are up and running, right? Now to get these results in proper visualized format, we can use we can set up Grafana. Okay, so let's do this as well one by one. This is the website I can go and I can install. let me come out to monitoring folder. First command this is. Second command to download the deb package. And then we are going to depackaged. So let's wait for this to complete. Okay. Now we should be able to see some command to start, right? So this is the command by running which I can start the Grafana server. Okay. Click enter, and we should be able to see the Grafana server on port. Let me get the IP address of the runner where we have set up Grafana, and we should be able to access the Grafana on port 3000. You can see it is up and running. Great. Now by default, the default username password is going to be just admin, which we need to replace. So login first, and then let us create a new password, which is going to be I'll just put Aditya. Submit. Okay. Now this is good, right? And this is the dashboard that you'll be able to see first time when you log in. Correct. And we have these options, so and so, connections, data sources, right? So in data sources, we can connect to our data source, which is going to be Prometheus. This is right. Open this. Okay. This will be the Prometheus. Then URL we need to put. So our Prometheus URL is this one, till 1990. I will copy that, put it here. Okay. And then we can just go at the end, click on save and test. You can see it's connected. Okay, it's running fine. Now we can go to dashboard and we can create dashboard. So we can click on new, click on import, and here you need to put either ID or the URL, right? Where do we get it? So we can simply go on Google, search Grafana dashboard, for which we want black box, right? And open that. So you can see this is the ID, right? I have copied the ID. I will paste it here. Click on load. Okay, and automatically it will load. You need to just select the data source, import, and now you can see all this information. I can put like last 5 minutes, and you will be able to see everything. This is our website, okay, which is getting monitored. This is our 𝗏𝗏𝗃𝗀. Okay, all those information, HTTP duration, probe duration, everything will be able to see. Okay, so this is our black box dashboard. Now what we need to set up now is going to be node exporter. Okay, so let me see. This is the node exporter. So this we need to set up. Okay, so let's do that as well. Okay team, so now what I want exactly is the runner that I'm using for building applications. So I want to do a system level monitoring of that. For website, I have done the black box exporter website monitoring. For the runner, I'm going to use the node exporter. Okay, so now what we need to do, here I'm going to set up a node exporter as well. Where do I get it? You can simply go to this website, prometheus.io/download, get the package for Linux, go back here, and we can use wget, download the package for node exporter, and let us extract it. Okay, and let us remove the tar file. Okay, also I'll just rename this node exporter so that it's kind of like user friendly name. Okay, so node dash exporter. Okay, now it's much better, right? Okay, so let us go inside node exporter. We have these files, right? So now I can execute the node exporter file. slash so and so and ampersand sign to run it in background. So it is also running and default port is 9100. So let us access it. This is the runner IP address, right? Copy that. We can put it here. Default port 9100. Okay. So you can see node exporter is also up and running, right? Now what we need to do, so we need to add this configuration inside 𝗏𝗏𝗃𝗀𝗃 file again. So I'll copy this. This you can get in the like from the documentation I'll create. Okay, and let's go to Prometheus file, cd Prometheus. Next up team, we need to edit the Prometheus YAML file again so that we can add the target for our node exporter. Okay, so let me remove the previously added, it was actually wrong, so let me add the correct one. It is going to be this. Okay, this is actually okay, this should be fine. Let me save this and let me try to run Prometheus again and let's see. Okay, so Prometheus running fine now. We can go to the Prometheus dashboard, refresh the page once, and node exporter is also up now. Sorry, it is in progress. Okay, so let's wait for this. Let me refresh the page and it should be all of them are up and running now, right? This is good. Now we can go to our Grafana dashboard, save the current dashboard. Okay, and now let us create another dashboard. Import, and we need to get the ID for this for node exporter. Okay, so what I can do, I can put here as node and node exporter. We can get the ID, we can put it here, load, scroll down, select the data source which is Prometheus, click on import, and yes. So all these things that you are seeing, this information about like memory usage and everything, this is basically about the our GitHub Actions runner. Okay, and this I can switch to every 5 seconds. So every 5 seconds this is going to get refreshed, and yeah, you can see all the information that we have. It's about the completely available to us, right? This is good. CPU, busy system load, RAM, how much is used, swap, it's NA, root, FS used. Okay, so all the information we have. So basically we have both the dashboard ready, right? One is node exporter and one is black box. So in this way we can perform the monitoring. Okay, I hope this was useful for you, and if it was, then make sure to give it a like. Okay, and have a nice day. Thanks for watching.